Hello everyone, this is Anish Raj from the Department of Artificial Intelligence and Data Science. So, my final year project is speaker diarization with transcription in multi-speaker audio. And since I'm having some issues with my camera, I'm presenting it using the video. Let's go through what are these things in the project. Um, First of all, we start with the abstract part here. First of all, speaker diarization means the core purpose is to find who spoke when. Because nowadays finding who spoke when many audio is becoming a cumbersome nowadays. So we have built a speaker diarization model which detects based on transcription and the timeline. Yeah, as I mentioned, in areas such as meeting, interviews, podcasts, customer support, and calls, and many more, it fails to detect the speech to text transcription. So here we have built a speaker diarization with the help of OpenAI's Whisper model, and it was deployed using Streamlit and Docker. This project supports both WAV file format and as well as MP3. But for WAV file format, it works well, and since most applications face issues handling MP3, the same exists here. That's a little bit of innovation compared to modern methods. And yeah, the purpose of the project, as I mentioned about Streamlit, Docker, and other things, and transcriptions, and the proposed methodology. Here we will go depth about the tech stack. Um, Here we use the OpenAI system model and speech brain for clustering the speaker embedding extraction. And yeah, this will be the expert results and outcomes. We can easily find who spoke when with the help of timeline, in which is given in the form of minutes and seconds. It is user friendly since it is deployed using Streamlit, and yeah, it is used in real world processing, not with dummy dataset or test datasets. It can be used even with real world communication. For example, real world meetings, interviews, and things. And yeah, let's get into to the code which I use here. First of all, we will quickly jump into the architecture. The user first upload the audio file format, and then the audio will be pre-processed. And here it's the main part here, where the fire note audio speaker description, which is in the Hugging Face model, can be used for speaker diarization. It's a pre-trained model. It can be connected here with the help of APIs and other connections tokens, and the diarized transcription will be displayed here. And after that. Yeah, in that part, after pre-processing the audio, we are putting it to the speaker diarization model, and it segments multiple speakers based on the received audio. And after that, it will be sent through the OpenAI Whisper speech to text transcription, and it will be containerized for deployment. And from both the ends, it will be containerized, and it will get into a file storage with help of Docker. And finally, coming to the final part, we are using Streamlit since it's a user-friendly application to deploy apps. We are testing it with the above files mentioned here, these things, and we are uploading the audio files there and checking how the efficiency of the output will be. Um, yeah, coming to the requirements, we have used Python recognition framework, Spynote audio, as I described, which is in OpenAI's Hugging Face, which is in Hugging Face model, and speech to text model for OpenAI Whisper. And for speaker embeddings, we have used SpeechBrain and web framework, obviously Streamlit and containerization Docker. And these are normal things, so VS Code, GitHub, and Python. And these are some of the dependencies used in the project. And yeah, The output will be exactly look like this. For example, speaker 1 has spoken during the time duration of 5 seconds and 25 seconds. Meanwhile, speaker 0, yeah, I have not mentioned about speaker names since I have used some sample data set. And for speaker 0, it's he spoke between 10 to 15 seconds. That means here 12.5 or something like that. And for speaker 2, he spoke between 0 and 0 to 4, I guess. And then he spoke between 6 to 12. Yeah, like that. Okay, we'll go deep into the coding part here for the hardware and software things. Hardware, we low end PC itself even run this software. We may not require much high end configuration here. And wait 1 minute. Yeah, it's the architecture model and it's a Docker file. Um, Here we have used Python image, yeah, from Python for that. For Docker users, everyone knows how Docker works. So for the image part, we have used this and system dependencies. We have to use FFmpeg and Git. And for system dependencies and audio processing, we have used FFmpeg. These are nothing but the files which are necessary to run the entire model. Docker users, everyone knows how it works. And here is the working directory. Um, Here's the working directory to execute our app and copy the requirements for file text for stashing purposes. And pip install or for some other dependencies installation and copy the project. We are using the port 8501, which is default for Streamlit. And for starting the Streamlit tab, we are putting the entire thing into in configuration and setting up the port and as well as the address. And what else? App. Yeah, app.py. This is fully in the form of Streamlit files for user-friendly web interface. So this part is totally for implementing the necessary libraries for the project, and it is for the project. It is for the page configuration for the page title, page icon, and the layout will be in the form of wide. And here it's same as HTML and CSS. We are using the font size, weight, text align, and other things. And the markdown for uploading the audio file, text speakers, and things. And this segment of code is entirely for uploaded files. Um, yeah, yeah, it will be in the form of JSON format. During the timeline, this wait a minute, I will show you from this part. So this part is fully in the form of for the status of the uploaded audio. And here is the summary status: how many number of speakers, the total time, and the detected languages, and everything. And what else? I earlier described about JSON format. Here we will get about download button we will receive for downloading the JSON file, which consists of the speaker and timeline. And yeah, that's it for here. This and all for downloading summary and other things which are not necessary. And docker.ignore. We should ignore these files. So I have put it these in the since these files need not to be containerized, right? So we have now included in the docker.ignore text. And for final pipeline, yeah, this is the final pipeline. This is the Python file for importing our Hugging Face model and OpenAI Whisper model. Yeah, I have described there. And as well as the libraries and the loading the model. We have to get the token from the Hugging Face site and we are loading the model here. Create output, yeah, this and all. for the output for file and for saving the JSON format. And here is the transcription of yours. And for the timeline, we are plotting using a generate image. We are using pld.figure matplotlib for here. And this part is for detecting the language, and this is for assigned roles like clinical keywords, how long. We can even expand this data set here. It's for just sample to know what are the basic words we will get for assigning the roles. And here is for the diarization part, how much speakers, how much segments, and you are appending it ID, speaker, in second, short second, what kind of text, what kind of language, everything. And with the help of Whisper model, we are converting the speech to text, which is the crucial part here. And here we are detecting the language, and this is for the roles. We can modify it, and yeah, that's it. And this is the final requirements.txt, which will be installed before the deploying the project. And this is what the output will look like. It's example output, but this is the same output which should be provided. Can be plotted with help of matplotlib and other libraries. So that's it for the project's entire thing. And thank you.